So here's a few examples from this periodic trends practice, and hopefully on this number 3 here, where there's the summary, you're understanding that the atomic radius increases as you move this way and increases as you move down. So francium is the largest element. So atomic radius is the largest here. And that reason that's happening is you're getting electrons added to energy levels that are further out. Remember from the electron configurations, that's principal energy level 1, 2, 3, 4, 5, 6, and 7. And so the bigger the number, the further they're out. So francium's the biggest element. And they're actually getting smaller as you move to the right because you're usually adding electrons to the same principal energy level while you're also adding protons at the same time. So the protons are pulling in. So the smallest is helium. The ionization energy, though, is the opposite trend. So ionization energy increases that way. And then there's the greatest ionization energy up at helium. And the trend there is, the rationale is it's the opposite. If helium is the smallest, then it's going to take then the electron's close to the nucleus, and it will take a lot of energy to pull that electron away. So it has a high ionization energy, and that's what ionization energy is, how much energy it takes to pull an electron away from an atom. So the smaller it is, the closer to the nucleus the electron is, the more energy it'll take. So the trends are opposite. So once you understand those trends, then you can start looking at elements and comparing who's the smallest atomic radius, the largest out of a group. And so that's what I'll show you some examples of. I'm going to do this, the first one right here. So we have iron, scandium, and selenium. And what you want to do is find them on the periodic table. There's iron, scandium, and selenium. And then notice that they're all in the same period. So when you go back up to this here, you want to, when it says relative placement, you want to place them like you saw them on the periodic table. You saw them all in a row, so that's what you're going to do in the same order that they are in the periodic table. So it was scandium first, and then iron was next over to the right, and then selenium was next. So that's the relative placement, just like you saw them on the periodic table. So what's the trend for atomic radius? Atomic radius increases as you move to the right and down. Well, there is no up-down, but there is a left-right. So it's increasing that way. So the smallest will be the selenium, and the largest will be where the arrow's heading, and that'll be scandium. Now when you're doing ionization energy, it's the same placement. You have scandium, iron, and selenium. That's the order. But what's the trend? Well, the trend is the opposite of atomic radius, so it's increasing in that direction towards the right. So the lowest ionization energy will be over here with scandium, and the highest ionization will be where the arrow is pointing. That will be selenium. Okay, so here's another one that I'm just making up. I'm picking 3 elements. We've got boron, gallium, and indium. And then you want to, let's see, go find the periodic table and then find them on there. We've got boron, gallium is right here, and indium is right there. So they're in a column. So we're dealing with looking at the ones that are in a column. And so you write down the order that you see them in the column. Boron's up top, gallium's below it, and then indium is below that. And then if you're looking for atomic radius, which is the direction it increases, well, it increases to the right and down, so it's increasing in that direction. So this one will be the smallest atomic radius, and this one will be the largest. And then when we're doing ionization energy, same order, boron's up top, and gallium, than indium. That's how you see them in the periodic table. But the trend for ionization energy, it increases to the right and up. And so it's increasing as you move up. So this one will be the lowest ionization energy. And then boron, where the arrows are pointing, that's going to be the greatest ionization energy. All right, so there's two examples, and I'm going to do another one in a second. So here's another one that I'm just making up. I'm picking three elements here: carbon, oxygen, and sulfur. And they're not in the same period or in the same group. They've got this shape like that going on. So let's see what happens there. So we've got carbon, oxygen, and sulfur, and that's the order that they, or the placement that they are in the periodic table. They're making that shape there. So for atomic radius, how does it increase? Well, it increases to the left and it increases down. Well, this makes it easy to find which one's smallest. So no arrows are pointing towards oxygen, so that one must be the smallest atomic radius. And there's arrows pointing to both the carbon and the sulfur. So which one of those will be larger? Well, if you look back at the periodic table, the carbon here is in period 2, and the sulfur's in period 3. So which one's going to be larger? Well, the one that's filling electrons in the further out energy level. If it's period 3, then that's energy level 3. So that's going to be the largest one there. So this is period 2, that's period 3, and that's also energy level 2 and energy level 3. Those periods match up with the energy levels. All right, so what about ionization energy for them? Well, they have the same placement. Ionization energy increases to the right, and it increases as you move up. So the arrows are pointing towards oxygen, so that must be the greatest ionization energy, and that makes sense because it's the smallest. The smallest it is means that the electrons are closer, or the furthest out electron is close to the nucleus, and so it's going to take a lot of energy to remove it, so that'll have the greatest. And then what about the other two? Well, if you know which one is largest, then you know which one's going to have the lowest ionization energy, because the largest one, the electrons are furthest out, and it does not take as much energy to remove them, so that one will have the lowest ionization energy. Okay, so I hope that helps you figure out how to do these here, and then if you get stuck, you can check the answer key also.